cosine theta. Do we have any other independent formulas?
Y is equal to mg cosine theta? No?
Okay, that's not independent. That's problem specific. Because if y minus mg cosine theta is 0, then it turns out that y equals
that.
Friction equals mu times y.
All right, which mu are we using?
Static.
Well, that would static imply that like it just got. Static implies that the acceleration is 0.
No, static. Static implies, I guess, 0 with respect to the object it's touching.
It's moving down the ramp.
It would be kinetic. The key here, dynamic. Equilibrium, the acceleration is 0. Dynamic equilibrium, it's moving at a constant velocity that's not 0. Static equilibrium, it's not moving. So the fact that I said dynamic equilibrium tells me that it is moving, so this is mu sub k. So now this becomes mg sine theta minus mg cosine theta minus mu k, mg's cosine theta. Yeah, let's see if I can do that better. Mu k mg cosine theta equals 0. So all I've done is I've taken that and plugged it in for my y there.
So question. You'd only use static friction mu sub s if the object is not moving within respect of the other object.
Right, that, we used it the last time because we did not know, so we just assumed and so tried to see if the answer made any sense.
Okay, but didn't we know that both of the boxes were moving?
In the last case, once we got a positive acceleration, we knew they both would be moving, so we have to switch over to k.
So in the beginning, we didn't assume that they were moving, even though the box.
In the beginning, correct.
Okay, all right.
Right, Giovanni?
Could you add mu k mg cosine theta to 0 and then divide it all by n to take out mass and show?
Absolutely. So this comes over, mg cancels out, and we're left with sine theta equals mu k cosine theta, or mu k is sine theta over cosine theta. So the tangent of 53 degrees would be 1.3. So it's somewhere around there. Yeah, somewhere. There's some rounding I did. What should the units be?
Wait, no. What is that number? I wasn't paying attention.
Right, that 1.3, that's a line. If 53 degrees is roughly the angle for a 3-4-5 triangle. So
1.327.
sorry, but again, what are the units?
Meters squared. Wait, no.
This
That's
means
not.
mu k.
What'd you say, Giovanni?
Mu k.
No.
Just meters.
Pardon?
Just meters.
No. We found this by doing the sine of 53 degrees over the cosine of 53 degrees. What are the units? If you take the sine of an angle,
Oh, degrees. Or radians. Never mind. I'll let you.
That was my first thought.
If you recall, the sine of an angle is a ratio of sides. What are the units? Well, if you take the sine of an angle, what are the units?
Whatever units that's thing, it's the hypotenuse or whatever.
But if you do a ratio of sides, so if I've got so if this is a 3, 4, 5, let's say that 3 meters, 4 meters, 5 meters, that's theta. The tangent of theta would be 4 meters over 3 meters.
No, it's me.
How's yours?
Was that Giovanni?
Cancels out.
Cancels out.
So no, you can.
No units.
Just like we have right here, there are no units after it. That's a trick question. Is that, that's a trick question?
I don't know if it was a trick question, it was a question.
Yeah.
You can proudly stand up and say there are no units.
In the initial wording, what's that little northwest arrow next to it? The subscript.
Down here?
Yeah.
That's a K.
Okay.
I probably stated it, but another reason we put the sausage was there is again so that we see what Pete had already might look like.